Alright, here we go. We're talking about section 1.9 in Math 3. This is multiplying matrices. I've got two very basic 2x2s. I've labeled them. This is matrix A and this is matrix B. Okay, I'm going to go over some definitions and some rules first, and then we're going to talk about how to multiply. The first thing, in order to multiply matrices, you have to look at this number and this number. They must be the same in order for you to proceed. Okay? If those inside numbers aren't the same, then you can say not possible. The only way it's possible to multiply is if those two inside numbers were the same. So I could give you a problem and I could say 3 by 1 times a 1 by 4. Is that possible?
Yes.
Yes, yes it is. Or I could say a 3 by 5 and a 4 by 5. Is that possible? No, it's not. Inside numbers aren't the same. Not possible. Okay? Questions? The other thing that those numbers tell you is that the outside numbers here and here give you the outcome. Outside numbers give you the outcome. If the outside numbers are 2 and 2, then that means that our answer matrix is going to be a 2 by 2. It tells you the dimensions of your answer. Okay? So back to this example, 1 and 1 were the same. That meant, yes, I could multiply, but what would the answer be? It would be a 3 by 4. Even though this is a 3 by 1 and this is a 1 by 4, the outcome would be a 3 by 4. And it is helpful if you're multiplying this and you say, oh, it's going to be a 3 by 4, and you go ahead and say 3 rows and 4 columns. Go ahead and dash it out so that you know what you're trying to shoot for, that you have 12 slots to fill. Okay? The outcome is important. It changes for each problem. In this problem, I'm doing a 2 by 2 times a 2 by 2, so obviously the outcome's a 2 by 2, and I know I have 4 slots to fill. That's not that hard. But when I do problems that are a little different, it can be helpful to go ahead and dash out what you're shooting for, what your outcome is going to be. Okay? Let's do one more example like this. First of all, if I have a 2 by 3 times a 3 by 4, is it possible? Yes or no?
Yes.
Yes, it is. And what is your outcome going to be? A 2 by 4. Okay? It's not a hard concept. Make sure you have it written in your notes. Questions? Did you have a question? All right, anybody else? All right, good. The next thing that we need to talk about is that multiplication is not commutative when you're doing a matrix. If I say 3 times 4 and I get 12, is that the same as 4 times 3? Yes. Regular multiplication is commutative. Doesn't matter if I say 3 times 4 or 4 times 3. I get 12 either way. But AB, meaning the multiplication of matrix A times the multiplication of matrix B, is not equal to BA. And that's unusual, right? That's different than most things that we do in mathematics. Most of the time, multiplication is commutative, and that's not a big deal. In matrices, it's not commutative. Write that down. Multiplication of matrices, multiplication of matrices is not commutative. Okay? On the test, it may say find AB, and then it says find BA, and there might be somebody who write down the same answer for both. They're not the same. Okay? The last thing I need you to do is write kind of the formula down. There actually is a formula for a 2 by 2. It's in your book on page 43. Don't even look there. I'm not making you write that down. What I want you to memorize is the process. And that's what I'm going to write on the board. Process. The process of multiplying matrices is rows times columns. If you remember that process, you'll be okay. You'll get the problems right. You won't have any. It won't be that hard of a problem. Rows times columns. I know you don't know what that means yet, but write it down. And when you're thinking about these problems, you're doing them tonight or whatever, look at rows times columns. Okay? Questions? All right, now we're going to do our first example. I'm going to erase some to give us, I'm going to try to leave this. Let's do this. Read 3, 6, 7, -1. I should be able to remember that. 3, 6, 7, -1. Is that what it was? Mm-hmm. And then here would be 4, 2, 3, 8. Okay, thank you. -8. -3 or -8? -3. All right, here we go. 2 by 2 times a 2 by 2. First of all, it's legal. Second of all, our outcome's a 2 by 2. So immediately I give a little bit more room like this, and I'm going to go ahead and put 4 blanks. That's what I'm shooting for. Okay, sometimes it's confusing, and you're asking yourself, hey, what does my answer look like? Go ahead and say, hey, it's a 2 by 2, I got 4 blanks, this is what I'm looking for. All right, everybody's eyes up here, pencils down, I want to have full concentration. Okay, this is unlike anything you've ever done. Your calculator, you're not allowed to use your calculator on the test. It will do it for you, but we're doing these by hand. If I'm trying to find this first spot right here, this number that goes right here, I'm asking myself, what position is that spot right there? Well, it's not. I'm saying a question, but I need to be the only one talking. This is in the first row and the first column. Okay, first row times the first column. That's what you're thinking. First row, first column. Well, here's the first row, and here's the first column. What's our process? Rows times columns. So we're going to say 3 times 4. And it helps sometimes when students come into extra help and they're doing a problem like this. I physically make them put their fingers on the numbers that they're multiplying. Rows times columns. So I say 3 times 4, and I put a 12 right there. Don't write that down, just watch me. Then both fingers have to move. Neither one stays in the same place. What's my process? So where's this left finger going to go? 6. It's going to go to the 6. Where's this right finger going to go? Down to the -3. It's rows times column. And I put a plus -18 right there. It's always plus in the middle. That helps. Okay? It's rows times column. Obviously, in my answer, I'm going to add those two up and get -6 right there. But I'm saying this is the rough draft, this is the final draft. Okay? And you need to do it. Don't try to do too many steps in your head. Leave it as a rough draft, then come back as a final draft. Okay? Let's do this position. First question you ask yourself is, what is the position here? What is it in? It's in the first row, but it's in the second column. What's my process? So here I am. Here's my first row, and where's my second column? Right here. So I'm going to do 3 times what? 3 times 2, and I get 6 right there. Plus, watch, both fingers move. 6 is going to be multiplied by what? 8, and I get 48 right there. 6 and 48. Add, always add in the middle. Okay, how about now? What position am I in? Second row, but first column. Second row times what? First column. What's the 7 going to be multiplied by? 7 times 4. Then both fingers have to move. 7 times 4 is 28. Then watch. Both fingers move. What people get in the problem of is they want to say 7 times 4 and then they want to say 7 times 3 or -3. And they get it wrong. Both fingers move. 7 times 4 is 28. -1 times -3 is +3. Okay? Then the last one, what position is this? Second row, second column. So I got second row, second column. 7 times 2 is 14 plus, what is this? -1 times 8 is -8. Then on my final draft, I simply have to add those up. 6 plus 48 is 54. 28 and 3 make 31. 14 and -8 make +6. This is the answer. This is the rough draft. This is the final draft. This is the answer. Okay? What do we find here? If this was A and this was B, we simply found A times B. Matrix A times matrix B. AB is equal to that stuff. Okay? Questions? Any questions? Yes?
How would you apply multiplying matrices in the real world?
When we do problems that look like this, great question. We can make a matrix out of it. And we can solve that problem using a process of matrices, and it's a lot easier. right? What would the matrix be that goes with that? Right? We have three unknowns. We can't use substitution, elimination, or graphing, right? The matrix would be 3, 2, 1. See where I got those numbers?
Yeah.
How about 4, -2, -1?
Yeah.
Where am I getting those numbers?
The coefficients.
Very good. Correct math work. Coefficients, 1, 1, and 3. This would be equal to the matrix of what? 11, 4, and -1. And we have a way of solving that. Okay? Not that we're going to get into right now or even this year, but in Math 3, next year, we'll get into that. But that is a real-world application of using matrices. Okay? Because it allows us to organize this data in a quicker, easier, calculator-friendly way. Okay? Good question. All right. Let's multiply two more matrices that have different dimensions. All right, let's try this. 3, 2, 1. What are its dimensions? 3 by 1. And let's do a 1 and a 4. What are its dimensions? A 1 by 2. Is it okay to multiply those two matrices? Yes, but they're really weird looking, right? This is a 3 by 1 and this is a 1 by 2. What in the world is our answer going to look like?
3 by 2.
It's going to be a 3 by 2. And that's why I tell you to go ahead and say dash, 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 dash. 3 by 2. Now you know you're looking for 6 slots. You have 6 different things to do. Okay? First question, Brunson, what are you going to say? Right here, put you on the spot. All right, so this is in the first row and what? And first column position. Here's the first row. Here's the first column. What do we do with these two numbers?
Multiply.
We multiply and we get 3. And that's it. There's nothing else to move. I can't move this way because there's no number there. I can't move down because there's no number there. So it's just 3 times 1. There's no plus sign. Okay? How about this position, George? What is this position?
3 times 4, which would be 12.
You're right, but what position?
That's
First row, but
second column.
second column. So here's the first row, but now we can move over to the second column. Exactly right, what you said. 3 times 4, and we get 12. Okay? How about this position? Second row, but first column, so I put a 2 there. How about this position? Second row, but second column. So right here, and I put an 8. You get the hang of it? All right, how about this one? 1 goes here, and then how about here? 4 right here. Okay? Questions? Was that hard? Does it make it easier when you dash it out and you have a goal to shoot for? Right? I would strongly recommend that you do that. All right, what's the hardest type that I would give you? As big as I'm going to give you.
With the scalar and parentheses.
I could put a scalar in there, but they don't typically do scalar and this. You would do the multiplication first and then multiply with the scalar. The answer is a 3 by 3. That's as hard as I'm going to do. So let's do one of these before lunch right here. If we have time, let's see here. 3, 2, 1, 0, 1, 2, and 1, 0, -1. Why is it nice if you have some zeros thrown in there?
Because the answer is 0.
Stuff times 0 is 0, right? That makes it a lot easier to add up 0. Okay? What's binary code? 1 and 0. All computer code is binary, right? 1 and 0. It's either on or off. Okay? How about 4, 3, 2, 1, 0, -1, -2, -3, and 7. What are we multiplying? A what times a what? A 3 by 3 times a 3 by 3. What's your outcome going to be? A 3 by 3. You have 9 dashes to fill in. I'm going to do it big here, because you need lots of room. 9 dashes. Let's do the first couple. I'll get you started, and then you can fill in as we go. All right? So here we go. What position is this? First row, first column. So my fingers are right here. They're on the first row, and there's the first column. I'm going to have 3 things going on. Jacob, what am I going to do first? 3 times 4. That's first row, first column. 3 times 4 is 12. All right, then watch. Both fingers move. Which way do they move? This one moves left. This one moves down. Now what is it going to be? plus 2. Am I done?
No.
No, I got to go more. There's that one times that one. What's it going to be? Plus -2. Just stay with your plus in between each time. You won't get confused. I love the cards. Go ahead and go to lunch. We'll finish up afterwards. Hit stop on the thing for me and hand